So, very good evening my dear students. I welcome you all in the YouTube live session of Python programming language subject. The topic which we will discuss today is the Lambda or anonymous functions available in Python programming language. I will also discuss one important question, the life development cycle of Python. As few students has asked me in the previous video that I have to explain this topic in more detail. So, first I will start with the discussion of Python programming development cycle. So, I have to start with this topic today. First I will tell you about the traditional development cycle, the programming cycle followed by some of the high level programming languages like C or C++ or Java. Then in the second part we will discuss Python's development cycle, and at last we will discuss the Python's development cycle with module reloading. So, we will discuss module reloading component in Python programming development life cycle. So, actually there are two kind of development cycles in Python, but before that let us start with the traditional development cycle. As you know, every programming language allows you to write a program, to compile the program, then to execute the program to get the output. Some programming languages provides you the functionality to change the parameters or values or the size of memory at compile time only, which means while you are writing the code, at that time you can change the source code, the type or the size of the parameters or arrays or variables, etc. But during the runtime, neither you can increase the memory, nor you can decrease the memory, nor you can change the size of the behavior of different variables. But nowadays the advanced level programming languages provides the functionality of runtime interpretation and changing of the code. You need not to stop the program, again open the source code, make the changes in the source code and then recompile the code and then re-execute. That is the main time wastage component in traditional development life cycle. But in Python development programming cycle, you need not to stop the program and go back to the source code, change it and recompile it. The compilation or recompilation phase has been eliminated. So, let us have a look. First start the application. Like I am writing a .c program. I am writing a program in C programming language. I have opened the program. First I have started the application, that is the C compiler, Turbo C++ compiler or Borland C++ compiler. So, then you test the behavior. Test the behavior means all the libraries and linkers are loaded properly into the compiler, so that when you will compile the program and then you execute the program. So, as you have seen in the C programming language, when you press Alt F9 it will compile the code. In that part it will test the behavior of all the environmental components or variables available. Then after testing the behavior, you need to stop the application. If you are not satisfied with the required result, you need to stop the application and edit the program code and recompile it. This is the major part which is now may be eliminated in high level programming languages. Recompile the code again and again. You need to edit the program, that is your source code. You need to change the source code, and then because earlier the executable file was the .exe file, this is .exe. In this part .obj file is created. So, from .c file, first .obj object file will be created, then from it .executable file will be created. So, .c, .obj, these are the files which prepare the executable code and you run the program. So, when you stop the application, then you need to edit the source code or the program code, then you need to recompile the code so that a new object file will be created. This new object file is actually the file generated by the system and the compiler, which has system specific configuration. If you copy this object file and replace it in another system, the file will not work properly, because this file contains the ASCII character, the binary code related with the hardware and the software which you are using. Another machine has different hardware and software. In that case, this code need not to be recompiled, need to be compiled again, so that a new obj file will be created. After that, at last you relink the executable code. Then you need to start the application again and go to step 1. So this is a 5-step process of traditional development cycle. But in Python, the first version of development cycle contain only 3 steps. 2 steps has been eliminated. As I already explained you in the previous class, the Python language does not need the compilation or any recompilation of the code. It simply tests the behavior, stop the application, edit the code, and simply once again start the application. You can start the application directly after editing the program code. No need to recompile, this step is eliminated. No need to relink the executable code, or simply you can say no need to create the executable code once again. Directly edit the code, start the application, test behavior. Again, test behavior means you want to check the output, whether the required output is okay or not okay. Then stop the application, edit the program code. So this is a simple 3-step Python development cycle. But here there is one problem that can also be eliminated in the 2 part. You need not to go back to the start of the application. You simply edit the program code and test its behavior without stopping the application at run time. You can change the code at run time without stopping the application. You can change the code and again re-execute it, or you can simply say test the behavior. So in this case, as you see here, there are 2 development life cycles of Python programming language. First is a 3-step process, another is a 2-step process. Here you need to stop the application, means the code which is under execution need to be stopped. After that it will be edited, and then again you need to start the application. Here you can see the arrow, it is not going to this step, it is simply going to the test behavior. The application once started remains in execution state always until and unless the program has not finished its complete task. So this is called as Python development cycle with module reloading. You can simply reload the module, no need to restart the application. So this is Python programming development cycle when compared with traditional programming development cycle. It is a 5-step process, it is a 3-step process, and it is advanced 2-step process. So this question is very important from exam point of view. In every exam this question generally comes. So now coming to the today's new topic, Lambda or anonymous functions. In Python programming language, we use the keyword lambda. It is a reserved word, or simply you can say it is a keyword. It is used to define anonymous functions. Now anonymous means the function which does not have any particular type. Anonymous, without any name. This function does not have any unique name. Anonymous, in the next slide I will discuss the syntax as well as the example of how to create and use this lambda or anonymous function. So anonymous functions are not defined in the standard manner using def keyword. As like simply you define the function, I discussed in the previous class, if you want to define a simple standard function, you need to use the keyword def. Def means define. So but anonymous function does not need the standard method of defining the function by using def keyword. It can take any number of arguments but return only one value in the form of an expression. Now you have to carefully understand this point. In lambda function or anonymous function, you can take any number of arguments, you can pass any number of arguments in any order, but you can return only one value in the form of an expression. You have to return only one value, that should not be any constant or a variable. It should be in the form of an expression, and that will be the output of that function, and it can take any number of arguments. Now let us take, first I'll explain few theoretical parts, then we'll come to its programming example. So it cannot be direct call to print as lambda requires an expression. You cannot directly make a call as like to print a lambda value or lambda expression. They have their own namespace and cannot access variable in either in local or global namespace. Every function has its own space. The variable which are defined inside the function, they have a local namespace. The variable which are defined outside the function with global keyword, that has a global namespace. That we have covered in the beginning videos of this particular subject, the type of functions, global variable, local variable. But these lambda or anonymous function, they have their own namespace. They cannot access any variable which is either locally defined within the body of any function or globally defined outside the body of any function. You need to note one more point. They are not equivalent to inline statements in C or C++ programming language. As you know, every programming language contains some inline statements. These functions are not like inbuilt functions or inline statements defined in any programming language. Its syntax contains only a single statement. It is a one-line statement function. You have to define the function by following the particular syntax, and it is a one-line function. Now let's come to the example of this function. This first I will tell you about its syntax. You need to write the keyword lambda. This is the keyword lambda. Because there is no name of this function, that is why it is called as anonymous function. But because it is a lambda function, the lambda keyword is used to start or initiate the function with any number of arguments. Here I have chosen square brackets. Square brackets means the number of arguments are optional. Either you can pass only one argument, then arg1 will be there. If you want to pass more than one argument, again the square bracket will start. After comma, write the name of the second argument. Then again, if you want to pass 3 arguments within this lambda function, again start the function and so on. You can pass n number of arguments within this lambda function and it will return. This is the output of this function. You need to take care about the syntax. A colon symbol is there, then the output in the form of expression. I will tell you expression like 2 plus 3, the output will be 5. Expression like a plus b, a minus b, these are the output in the form of expression. So let's come to the example of this anonymous function. The example is written inside this box. First of all, I have defined the function. This is the comment line because it is started with the hash symbol. I have taken a variable total. Total is equal to lambda. I simply return lambda, no name of any function. Then the arguments which I want to pass, num1 and num2. I have passed 2 arguments for this total variable and the output will be num1 plus num2. This is the complete one-line definition of lambda or anonymous function. Now the function has been defined. Now we need to invocate or call this function. So I have called it 2 times with the help of print statement. Value of total. Here total is defined as a variable which receives the value passed by this expression num1 plus num2. This value will be passed to this variable and this variable will return the output based on the expression given here. If plus operation is there, then it will give you the output as plus. If minus operation is there, then it will give output of num1 minus num2, etc. Now I have chosen first print statement. Print value of total, comma, total 825. So here the function has been called by passing the value. 8 has been stored to num1. This 8 has been stored here. 25 has been stored here. So 8 and 25 are passed. Their total has been done. The output is 33. This output has been transferred to this variable total, and this print value, value of total colon all these comes in the inverted comma, then the output 33. So the output of this print statement is 33. Now again I have called this function print value of total 56 and 15. Now you can see here num1 store larger value, num2 store smaller value. Earlier num1 stored smaller value, num2 stored larger value. So 56 plus 15 is 71. So now this is the example of lambda function. You need to understand it very carefully. You need to observe just 2-3 things very carefully. First of all, the name of the function is not defined. No name is given like addition, subtraction, multiplication. Only the lambda keyword is used, which means it is an anonymous function. Then the values has been passed, expression has been returned as an output which is stored in the variable, and we get the output as 33 and 71. Okay. This was all about the lambda function or anonymous function. Now we will discuss one very important problem, Tower of Hanoi problem. It is based on recursion in Python. Tower of Hanoi problem is actually a mathematical puzzle or mathematical statement which was discovered by the French mathematician Edward Lucas in 1883. Earlier it was introduced as a mathematical problem which then solved by the concept of recursion, and by using recursion the problem was solved, and then nowadays in so many scenarios this case study or this real time problem has been used to solve large size problem. It used the concept of recursion. There are 3 rules you need to remember before going to understand how recursion helps to solve the Tower of Hanoi problem. There are 3 rules. Let me discuss every rule one by one. Number 1, move only one disk at a time. There are some disks, some towers given here. You need to change the disk from one place to another. I will show you the diagram. Let's have a look on this diagram. There are 2 parts of this diagram. This is the initial state, this is the final state. There are 3 towers ABC, 3 disks, small size, medium size, large size, blue color, green color and golden color. The problem is you need to transfer the disk from tower A to tower B as like this one. This is the required output. I need to transfer the disks in the same order, like largest disk at the bottom, smallest disk at the top and the medium size disk at the in between. You need to convert from this state to this state by the help of this third tower C. It can work as a temporary buffer. So how recursion will help to solve this problem? First, understand the 3 rules of this problem. Number 1, move only one disk at a time. You can transfer one disk at a time. You cannot directly collect 3 disks together and put it from A to B. It is not possible. You need to move only one disk at a time. Second, rings must be in decreasing size. The rings which you want to transfer are placed in the decreasing size order. First the largest size disk, above it the medium size disk, above it the smallest size disk. So you need to place the rings in decreasing order, which means the small size disk does not come below the large size disk. The small size disk always come above the large size disk. So you need to move only one disk at a time. No move should result in a large disk on top of a small disk. As I already told you, you cannot take any such kind of move in which a large disk comes on the top of small disk. Very first, you can transfer only one disk at a time. Second, small disk cannot come below the large size disk. Now, third support or condition, for temporary holding a disk, the third tower can be used, the C tower. You can use it as a temporary buffer to transfer the disk from one place to another. So this is your Tower of Hanoi problem. Okay. Now Before discussing its program in Python programming language, let's understand the terminology or concept in how many number of steps we have to transfer the initial state into this final state. As there are 3 disks, I want to say you need 2 raised to power 3 step, which is equal to 8. If there are n disks, then you need 2 raised to power n number of steps. Here 8 steps are defined. So you have to use from beginning to final state 8 number of total steps and 7 number of movements. Okay. First, transfer the smallest size disk from tower A to tower B. This is the move. So pink color, here the colors are little changed. The top disk is pink in color. It is transferred from A to B. So we have transferred it A to B. Second step, the green size disk is transferred from here, from A to C. The disk has been transferred. Now at step 3, all 3 tower contains 3 different disks. The largest disk at the tower A, the smallest disk at the tower B, the medium size disk at the tower C. Now in 4th step, you need to move this disk from here to here. So here a disk from tower B has been transferred to tower C. Now after the 4th step, tower B remains empty. All 3 conditions are met here. You need to take care that only one disk is moved at a time. Second, the smallest disk always come above the large size disk. Here the smallest disk is above the medium size disk and the large disk is separate. Now in the next step, you have to transfer from here to here. The largest size disk is transferred from A to B. Now transfer back the smallest size disk from here to here. So actually this was the move. The smallest size disk jumped from tower C and put it into the tower A. Again, all 3 towers have 3 different disks, and all 3 conditions of tower of Hanoi mathematical problem are in permission. They are as per the requirement or the rule. Now a next step, transfer this green to middle part, because the largest size disk came at the bottom. Now middle size disk come above this largest size disk, and at last this smallest size disk jump from here to here. Means in the 8th step, we come to the required position. Tower A is empty, tower C is empty, the tower B contains 3 disks, and these 3 disks are in the order as per the requirement. So this is tower of Hanoi problem. Now by the help of recursion, how we can do it in Python? Recursive Python function, or you can say program, to solve the tower of Hanoi problem. This is a recursive Python function. First of all, the def keyword, because it is not like a lambda function or anonymous function as we discussed just before this topic. So you can take it as an example of a normal function in Python. So this example serves 2 purposes. You can explain it to explain the concept of recursion, as well as you can explain it to explain the concept of functions in Python. So def keyword is used here. Def is a keyword, that is why it is written in bold. Def is a keyword. Then the name of the function. Name of function is tower of Hanoi. You can give any name as per your choice. Within the bracket there are 4 variables or argument. Number 1, n, which tells us about the number of disks. We can either take it from the user, or we can either pass it directly as an argument to this function. Then source, destination and auxiliary. These are the tower. Source is the tower A, destination is tower B, auxiliary is tower C. So A, B, C, these are the 3 different towers called as source, destination and auxiliary. So these are the 3 tower. Now a colon symbol, because we know in Python a colon symbol always comes, then colon symbol. So def tower of Hanoi, n source, destination and auxiliary. If n is equal to 1, means only one disk is there. then there is no need to run the recursion. Just simply take out the disk from tower A, that is our source, and put it into destination, that is tower B. Simply return it. So it will return the output, move disk 1 from source, that is our tower A, to destination. But if there are more than number of disks, then here the recursion part comes. We are calling the same tower of Hanoi function within this tower of Hanoi function 2 times, because we have to move from one place to another, and third is used as a auxiliary storage, tower C, or you can say auxiliary is used as a temporary buffer. So here this is the logic of tower of Hanoi problem implemented in Python. Tower of Hanoi, n place taken by n minus 1. First tower source, then auxiliary come before destination, and destination goes last. Source, auxiliary, destination. So tower of Hanoi, first was ABC, then ACB, then C. In the second case, this is C, this is B, and this is A, CBA. You can remember it like that. You can also take the variable name as ABC if you do not want to keep it as source, destination, auxiliary. So initially source, destination, auxiliary, ABC, then ACB. Source remains same, that is tower A. B and C are swapped with each other. Then in third case, CBA, reverse of ABC. ABC, CBA. In between, reverse of B and C, ACB. So this is our logic. When you are calling the tower of Hanoi function as a recursion, you can call it, but before in space of n, you need to write n minus 1. So 4 arguments will be passed here, n minus 1, comma ACB, then again n minus 1, comma ACBA. In between these two, you just need a print message, move disk n from source to destination. So A to B. Which disk is moving from A to B, that will be calculated here. Now how to call this function? I have written the recursive Python function to solve the tower of Hanoi problem. So the driver code is, let's take value of n is equal to 4. Now you need to remember, here there are 4 disks. In this picture I have shown you where there were 3 disks. So 8 steps has been taken. So if there are 4 disks, then 2 raised to power 4, that is 16. Total 16 steps are required to transfer the all 4 disks from tower A to tower B by using tower C, and all 3 rules of tower of Hanoi problem are being followed. So now simply tower of Hanoi NABC. ABC are the roads, or simply you can say tower. N is the value of power. I have passed n as 4, and they are calling recursively to each other. Now this is the 16 step output for this tower of Hanoi problem. Move disk 1 from source to destination, move disk 2. So here are the disks which are moving from A to B. I have taken A as source, C as destination, and B as the third tower. So total 16 steps are required, and the output will be presented here. So this is the tower of Hanoi problem explained with the help of recursion in Python programming language. So till now I will show you a quick brief what we have covered today, then we will come to the next 2 topics which we have to cover. First I have explained you the Python programming development cycle. So this Python programming development cycle, how it is different from traditional development cycle, and 2 different types of Python development cycle. Then we covered the concept of Lambda function. So the Lambda function, or simply you can say anonymous function, it is a syntax of Lambda function. You can pass the optional number of arguments within this Lambda keyword, and the output will be in the form of expression, not in the form of an argument or simply a constant. So I have taken an example and its output here to explain the concept of Lambda function. Then we have covered the third topic today is the Tower of Hanoi Problem, the history of Tower of Hanoi Problem, the rules required to solve this Tower of Hanoi Problem, and the concept of recursion to explain the Tower of Hanoi, the initial state of Tower of Hanoi Problem and the final state which we want in the Tower of Hanoi Problem. So this is one of the example having 3 disks, so total 8 number of steps are required, and then this is the source code explaining the Tower of Hanoi Problem in Python by using recursion, and the driver code to give this output. So this is the required output, 16 step output of Tower of Hanoi Problem. Okay, now coming to the next topic of today's discussion, that is modules. It is a very important topic. What do you mean by module? As like packages, as like header files, there are modules in Python. In C language, we generally talk about we generally discuss about the header files which have an extension .h, like stdio.h. In C++, IO stream.h. The second was iostream.h. So stdio.h, iostream.h, these are the modules in Python. Now these are the header files in C language or C++ language. In Java there are packages like import. By the help of import keyword, we are importing some packages in Java. Now coming to the Python part, the modules allow logical organization of code. Logical organization of code means the code or the number of source lines which are logically connected with each other, they can be combined together into a single entity. That single entity is called as a module, because as you know, math.h header file contains all the mathematical related functions, inbuilt functions of C or C++, like the different functions are power of function or simply raised to power function, scale function, cube function, average, maximum, minimum, square root, cube root, etc. All these mathematical inbuilt functions are defined within a single header file, that is math.h. The stdio.h header file written here contains the functions like printf, scanf. Conio.h is one more header file which contains the getch or clear screen functions within defined this header file. Now modules contains the logical organization of code which have the similar kind of meaning. Grouping related code into module makes it easier to understand and use. So when we group the related code into different module, it makes it easier to understand and use this code. So we can group it together, and module makes it easier to understand and use. If the related codes are written separately at different places, it is very difficult to import them in our program and to use their functionality. So we just do the concept of grouping of related logical code. It can be used to define inbuilt functions, classes or variables. So we can use it to define functions, classes and variable. So modules in Python are used to declare or define some inbuilt function, inbuilt classes or user defined classes or variables of different type. It is actually a single file. A module is a file and may have runnable code. This file is executable in nature. The module contains some runnable code which can be called within some another file. So it is a file and may have some runnable code in itself. Now let's see module in Python. How to import the module in Python? First I will discuss the syntax, then I will tell you about its example. So to import statement is used to import the module. If you have seen in Java, I have covered Java in some of my previous classes, the import statement is used to import the packages in Java, packages or special libraries. So these imported libraries or packages contain some inbuilt classes of object oriented programming or some inbuilt user defined functions. Variables are defined in those packages, some scientific operations are defined in the form of a logically related code, and we can import it in our main program. but here you can see the import statement is used to import a module, not any kind of a package or any single file. Any Python source file can be used as a module. You have written a logically related code and stored it as a Python file, .py extension. Now you can call that Python file in some another Python file in the form of a module. For that you need to require import statement. So any Python source file can be used as a module by executing an import statement in any other Python source file. As I already told you, a single Python source file which may contains only mathematically related or logical code grouped together, it can be called in another Python source file as a module. For that we need the import statement or import function. Now you can call any number of module together. If you want to call or import only one module, you simply write the name of the module. After that, the curly braces start. The curly braces means it is optional component. If you want to include more than one module in your Python source file, means there are two separate Python source files and you want to call both of those separate Python source files into your program. Then import module 1, import module 2. If you want to import n number of module, same a new square bracket will start, first comma will come. This comma is very important, it is a syntax. If you are importing something within the optional square bracket, it always start with a comma, whether it can be a list or a dictionary or a set or something like that. So here I am importing n number of modules, so n minus 1 number of square bracket are used here. So when the interpreter, because you know Python has an interpreter, there is no compiler, so this import statement will not be compiled at any place in Python. So when the interpreter encounters the import statement, it imports the module if it is present. It simply imports the module in Python if this module is present at that specific location. The location of the module, which is a Python source file, should be same as the main source file in which you are calling the module. If they are stored at separate location or different position in Python, then you have to give the complete path where that module has been stored so that it can be easily imported. Module is loaded only once, regardless of the number of time it is imported. You have to load when you are executing your Python program. First you have to load all the modules. After that, either in one source file or more than one number of source file, you can simply import that module. If you want to import a module only one time, even that requires the loading of the module. If you want to import module in 100 separate files, even then it requires only one time loading of the module. Regardless of the number of times it is imported. So you need to understand very carefully, this is the syntax of the module. Now how modules are used with packages. So let's have a brief look on the packages in Python, because import statement not only import the modules, the packages can also be imported. The inbuilt modules and packages or user defined modules and packages can be called with the help of import statement. So let's have a look on packages, then we'll cover the example of both of it together in the next slide. Packages are the namespaces which contain multiple packages and module together. Say I have defined 4 modules. If I am not combining or merging them together, I need to call these 4 modules individually. 4 times I need to call. And also if I need to call these 4 modules in 100 files, then total 100 calling functions are required, because every module is separate and you have to call 4 modules in 100 number of files of Python, then 400 transactions are required. But you can combine or merge the module and you can create it as a package. Packages are like namespaces. You have defined a namespace which contains multiple number of modules. It can also contain multiple number of packages. So it means a package is a combination of sub packages and modules. multiple number of packages and modules can be combined together and a larger size package can be defined. This can also be a Python file. So you need to understand very carefully, a simple Python file is a Python source code, a module is a Python source code, a combination of modules is a package which is a Python source code, or a combination of packages and modules which is itself a Python source code. So that is called as a package. It is a collection of modules in directory. The modules and packages which are stored in the package are in the form of a directory structure. They can be stored either alphabetically sorted, or they can be stored either as ascending or descending order. So the collection of modules in directory is called as a package. They must have init.py. Init means initialization. This is very important part. A package must have _init_.py file. .py means it is a Python file and init is a kind of a file. If you are not including this file in a package, that the combination of package and sub packages and modules will not be done successfully. So every package must have this _init_.py file. After that, it may contain sub packages or sub modules or individual source file. So a package is a kind of a folder which contains subfolders or files and this particular init file. Init.py can be empty or it contain valid Python code. So this particular file can be empty. You must need to store a file with this name, and within the package you must have to include this file. It can be an empty file or it contains valid Python code which has some logic defined inside it. So you need to take care of this thing very carefully. This init.py file should be there. Now coming to the example of importing a module and package. So let's have a look on this example. Package is in Python. init_.py indicates that the directory it contains is a package. This particular file actually differentiates the module and package, because a module can also contain some module or separate Python source files. Similarly, a package can contain modules only and Python files until and unless this file is not stored. Either it can be an empty file, it does not contain any source code, but it gives the file as a package name. It can be imported the same way as a module. For example, I have taken a package foo.abc. Here the module ABC belongs to a package named foo. So foo is the name of the package which contains only one file, that is ABC. It is a single module which comes in the package foo. Users of the package can import individual module from the package, as like encryption and decryption, zipping and unzipping of file. You can unzip a package and you can collect individual modules from that package. This is the functionality provided in Python. Like here you can take an example, import sound.effects.echo. This loads the submodule sound.effects.echo. It must be referenced with its full name. So here I am not importing the complete module sound and not the complete package effects. So within the sound, with the help of dot operator, I called the sub package effects. Within that sub package, again with the help of dot operator, I called a function echo. This echo can be a Python source file. This echo can be a package or sub package. This echo can be a sub module or module. So the user of the packages can import individual module from the package, and the import keyword you need to take care. This import is a reserved word or a keyword which is used to import a package sound.effects.echo. So this is an example of defining a module within a package like here, or importing a package or sub package with the help of import statement. Here first I have declared the module within a package, and this package must contain init.py file. This init.py file it must contain. Okay, this was the last topic which we covered today. Let's have a look on some practice questions which you need to practice at your home. The very first question is Python case sensitive when dealing with identifier? As we know, Python is not much case sensitive, but once it is dealing with identifiers, like variable name or another constants. Is Python is case sensitive or not? This kind of theory question generally comes in exam for 2 marks question or more than 2 marks question. So you need to find out the answer of this question and write at least 5 to 6 lines to support your answer. So now second is a programming code. You need to give just the what will be the output of this programming code. You can run this program in pythontutor.com. I will give you one visualization tool, pythontutor.com. You can run this code within pythontutor.com and you can check what will be the output. A 4-line code is given here, indentation is mentioned here. So what is the output of this following program? You have to check by yourself. Third is a source code written program. Write a Python program to find the index of an item of a tuple. First you need to declare a tuple, then you need to find out stored in that tuple the index, and you need to remember by default the index of an array starts from 0. So you have to write a Python program to find the index of an item of a tuple. The last assignment or a question for you is write a Python program to convert a Roman number or numeral to an integer. So it is a very simple program. We discussed few programs yesterday. I have covered the program like conversion of miles into kilometers. So it is a kind of a conversion program. Currency converter can also come in exam. The length converter, weight converter, here numeral converter question is there. So you need to find out the logic how to convert a Roman numeral to an integer, or its reverse may also come in the exam. How to convert an integer into Roman numeral. So these are the 4 questions given to you today as an assignment. In the next class we will start with the next topic of the Python. So thank you very much students. Today we are finishing this lecture, and the topics which we covered today, you can just watch this video once again and clarify your doubts. Thank you.